my poster presentation. My name is Mucio Leon, and I'm pleased to present our research titled Development for a Flexible, Non-Invasive Optical Urea Biosensor based on bismuth, bismuth sulfide, Bioglass 35S5, and silver nanoparticles heterostructure. This work was being carried out under the guidance of the Dr. Amanda Carrillo and Dr. Angel Sousa. Well, I would like to start with to I would like to start mention that the motivation for this research is the urgent need for a non-invasive, affordable, and reliable biosensors for healthcare. In particular, we target urea detection, which is an important biomarker for kidney health and metabolic conditions. The objective, our main objective was to design a flexible optical biosensor that can detect urea in biomedical fluids using heterostructure, bismuth sulfide, Bioglass 35S5, and silver nanoparticles. This material system was chosen to improve optical and electronical response, while the flexible substrate allows the integration into wearable applications. We can move to experimental part. Number one, we prepare of the pre precursors solutions and mix it to be used on point number two to deposit the thin films using chemical bath for deposit bismuth sulfide and spin coating technique for the Bioglass 35S5 with with silver nanoparticles. After we create the team field, we go to start the characterization of the team films using the equipment of UVVs, F, FTIR, and 4W. And number four, we expose the characterization of the team films to 10 different concentration of urea that goes from 1 millimolar to 10 millimolar. And after that, we characterize these responses to go to the final step, number five, to design the biosensor circuit using for with some bridge. Well, on figure number one, we can go to the results. Number one, we have on figure 1A the thin film of bismuth sulfide, and number 1B we have the thin film finished with bismuth sulfide, Bioglass 35S5, and silver nanoparticles. Moving to figure number two, we have the UVB spectroscopy confirmed that the absorbance and transmittance varied with urea concentration indicates a strong optical response. And figure number three, here we can see the band gap variation. The values shifted when urea was introduced, providing sensitivity of these films to analyte concentration. On figure number four, we can find the resistance of the biosensor increased as urea concentration increases, showing a clear semiconductor-alike behavior. Number five, the FTIR spectra confirmed that the structure stability of the the stability of the litmus sulfide, Bioglass 35S5, and silver nanoparticle structure under different analyte concentrations. Number 6, you can find the four Wheatstone bridge of the sensor based on the results from the figure number 4. We find that the same resistance from resistance 1, 2, and 3, we're going to be 1.3 mega ohms to find a difference when we introduce a different concentration of urea. And finally, in figure number 7, the biosensor circuit setup is showing here. Where we correlate the both optical and electrical changes with the presence of urea on the sample. Basically, on the left side, you can find the TM film. On the middle, you can find the circuit of the Whitson level, and on the right, you can find the display used to show the urea concentration. Well, moving to the conclusions, to summarize, we developed a flexible, non-invasive optical biosensor for urea detection. The films were homogeneous and reproducible using the spin coring methods. The device exceeded both optical and electrical concentration dependent responses. Also, the heterostructure show excellent semiconductor and sensing properties, validating its potential for biosensing. Most important, the biosensor work effectively on flexible substrates, which is promising for a wearable device. In future work, we will optimize the film stability, improve the electronic readout, and test the biosensor with more complex biological samples like human examples or mixing different allies. Well, once again, I would like to thank you for your time seeing my presentation, and thank you so much for your attention. I will be glad to answer